All right, I got it in a little bit of a rush yesterday, and I forgot to do something very important here on these examples. All right? And that's this. When we solve an equation, we've been in geometry all year, and we almost always needed positive values of variables because the variable almost always stood for a degree measure or the length of a segment. Okay? So I forgot this, and this is just my fault. I made a mistake. When you're solving an equation and you take the square root of both sides, there's something we got to do here. Oops, we got a minus 10 quantity squared equals 121. I want to take the square root of both sides. I forgot. Square root of 121 has two possible answers. If I square 11, I get 121. But there's something else I can square and get 121. Negative 11. So I have to put that plus or minus sign in front of there. What that means is that, and you don't have to write this out twice yet, but what that means is a minus 10 equals 11, or a minus 10 equals negative 11. So we are going to get the two solutions you expect with quadratic equations. So if a minus 10 equals plus or minus 11, a equals, add 10 to both sides, 10 plus or minus 11. Get two solutions, one using the plus sign, one using the minus sign. 10 plus 11, I get 21. 10 minus 11, I get negative 1. Or I could have worked it out over here the same way, right? Okay? So, I messed that up yesterday, so you need to fix that in your brain, okay? Because I said it wrong yesterday. Make sure you get that corrected thought into your head. And what I don't know what I was thinking, really. I just got stupid. I forgot the plus or minus. I guess I was thinking I'd get one answer, because if that was equals 0, I would just get one answer, because then that's when we would have 10 as an answer twice, and I don't know. Anyway, I messed it all up. Which means that if we look at 4b here, take the square root of both sides, I still get z plus 3 on the left, but on the right, instead of just the square root of 26, what do I get? Plus or minus the square root of 26. So z equals negative 3 plus or minus the square root of 26, which means z equals negative 3 plus the square root of 26, or z equals negative 3 minus the square root of 26. And unless you're compelled to turn those into decimal answers, leave it like that. Okay? You'll get lots of answers that look like that next year. So, have I corrected my mistake in your head? I have in my head. Have I in your head? Okay. Now, something else I just want to go through again is how come these perfect square trinomials work out the way they work out. It's all because of this and this. If you start with a binomial squared with a plus sign between them, you end up with the first term squared plus 2 times the first one times the second one plus the second one squared. So all we're doing is trying to be more efficient at going backwards than actually having to do the AC method. The AC method will work. It will. But by remembering that this came from this, we can make it a one-step problem. It's like those AT&T commercials. Which is better, slow or fast? Well, which is better, 1 step or 4 steps? 1 step. Okay, so that's what we're trying to do. Then the same thing over here. When there's a minus sign between them in your binomial and you square it, it's identical. You get the exact same trinomial except for a minus sign there. So all we're doing by memorizing the way this works is short-circuiting the AC method and going right to the answer. You can get away, for now, with not learning these, but it's going to cost you in the long run. A couple of examples let's do, and most of you have already done these, but let's go over just a few just to make sure we're all on the same page here, okay? Let's look at number 8. This is from worksheet 1, okay? Number 8. I'm going to reorder that. The book factors these in that order. I'm not going to. I'm going to make that r squared minus 26r plus 169. Then I'm going to see whether or not this is a perfect square trinomial. Is the first term here something squared? Yeah, it's r squared. So in your mind, you need to be thinking, oh, that means a is r. Is the last term a perfect square? Yeah, it's 13 squared. So doesn't that mean that b is 13? Is the middle, the negative 26r, is it 2ab or negative 2ab? Either one's fine. Well, it would be the negative one. So is this negative 2 times r times 13? It is. So it is a perfect square trinomial, which means our factorization is a, which we said was r, minus, because there's the second term, the bx term there is negative, b, which we said was 13, quantity squared. Okay? You with me? Now, if this were an equation, equals 0, equals 0, your zero product property says, well, if two factors multiplied together, and there really are two factors, right? It's just that each factor is r minus 13. Two factors multiplied together equals 0. One of them equals 0. Well, I could write it out twice. I could. And get r equals 13 or r equals 13. But the whole point of learning perfect square trinomials is to be more efficient with your time. I don't need to write it out twice, do I? So I do get two solutions, but they're both 13. Okay? You with me on number 8? All right, let's look at number 7. On number 7, we have 25c squared minus 10c minus 1. Is this a perfect square trinomial? Is our first term, is 25c squared a perfect square? Yeah, it's 5c squared. Is our last term, negative 1, a perfect square? Nope. If it was a positive 1, yeah, it's 1 squared. But it's a negative 1. You can't multiply a number times itself and get a negative result, can you? Because if the number is positive, positive times positive is positive. If the number is negative, negative times negative is positive. So when your last term is negative, it's not a perfect square trinomial. Okay? You with me on that? Let's look at 14. All right, I've got 16a squared minus 40ab plus 25b squared. Is 16a squared a perfect square? Yeah. What's its square root? 4a. So a is 4a. Is 25b squared a perfect square? Yeah, what's its square root? 5b. So a is 4a, b is 5b. That's weird, right? So is the middle, it's negative, but that's okay. Is the middle term negative 2 times 4a times 5b? It is. So this is a perfect square trinomial. So I know that, don't I? I know all of that. Now, 16a squared is 4a squared, so that's 4a. 25b squared is 5b squared, so that's 5b. Make sense? Does this help a little bit? Yeah. Down here at the bottom. All right, number 20. All right, let's go ahead and let's use our new technique. let's take the square root of both sides. So I've got the square root of y minus 3 quantity squared equals, and then when I take the square root of 6, what do I need to put in front of it? Plus or minus, because positive square root of 6 squared is 6. Well, so is negative square root of 6 squared, right? Negative square root of 6 times negative square root of 6 would be positive 6. Okay? All right, so that means I get y minus 3 on the left equals plus or minus the square root of 6. Add 3 to both sides. I get 3 plus or minus the square root of 6. So y equals 3 plus the square root of 6, or y equals 3 minus the square root of 6. I'll take that as the answer, or I'll take that as the answer. Either one's fine for now. Does that help? All right, any others on worksheet 1? Okay. All right. That's been bugging me ever since I realized I'd made that mistake on those first ones. So hopefully that helps you a little bit.